the absolute. And the reason that that's important to note is because you don't get that when you smell the synthetic vanilla aroma chemicals. Another thing about the infusion is that it's also a lot less expensive than the absolute. So even though it's less strong, I think this thing cost me about £1 per gram, so it's similar to $1 per gram. So that's already about 45 times cheaper than the absolute. So you got to think that even though the absolute is a lot more of a kind of star raw material and it's a lot stronger, it's probably nicer as well, you can't necessarily afford to actually go and use the absolute probably in most perfumery projects. Like if you wanted to go and buy this vanilla absolute and use it in a perfume, you could probably only really afford to do that if A, you're just making a one-off really special perfume, or B, if you're trying to make any kind of reasonable amount of perfumes. To get enough of this to make your perfumes out of is going to be so expensive that you're really going to have to be like selling the perfumes for a really high price. So it's going to be the real like top end of the luxury spectrum essentially in order to go and use this. And that again is a big reason why the vanilla aroma chemicals are so important, because most projects just don't have the budget to use the vanilla absolute. As nice as it is, it's just not possible in most situations. So next, let's talk a little bit about those aroma chemicals. So what I've got here is some vanillin, and that's that same really famous aroma chemical which I talked to you about just a little bit before. So if I go and smell this, when you smell vanillin, you instantly think vanilla. It smells of vanilla. And probably a lot more so if you hadn't just gone and smelled the real vanilla absolute. And the smell of vanillin, I would say, is pretty much what you would expect when someone says, I want a vanilla syrup or a vanilla, vanilla flavoring ice cream, vanilla flavored sweets, whatever it is. This is pretty much exactly the smell that you would think of. And yeah, it smells nice. Just because it's not the absolute smell, it doesn't mean it's not nice. It's really nice. It's this kind of sweet, creamy, all I can say is vanilla-like kind of smell. And you do get slight hints of it, I think, in the absolute, but it's really only very subtle. Yet this on its own is very powerful, and it's just this kind of pure, creamy, sweet smell. So obviously this is why then vanillin is so attractive, because it just smells really nice, and it's really cheap. So if you go and buy vanillin, you can easily get it for something like 10p, so that's like 0.1 of a dollar kind of thing per gram, and that's even if you're buying it in smaller quantities. If you're in the industry and you're buying it in massive industrial quantities, it's probably even a lot cheaper than that. So this stuff is really economical to use. However, not only is it really cheap, you also don't need a lot of it, and that's because vanillin is, I find, really strong. When I'm making perfumes with vanillin in, I find anything more than 0.5% of the final perfume being vanillin, then suddenly the whole thing is sickly sweet. So I find it's good just to use a trace amount. So this is almost pretty ideal because it smells really nice, it's really cheap, and it's quite strong, which means you don't even need to use much of it. Then in addition to that, it's also a base note, so it lasts a really long time. So all in all, vanillin is pretty much a star raw material, and it's also one that I really recommend as one of your first or most essential raw materials to any perfumer's palette. It's also one of the oldest synthetic raw materials. It was actually industrialized, so the reaction was discovered to make it on an industrial scale, economically or cheaply. That was discovered back in 1876 by someone called Ferdinand Tiemann, and it was only 3 years later, in 1889, that it was used in the perfume Jiki by Guerlain, and that is heralded as the first modern perfume due to its use of synthetics such as vanillin. Anyway, that's enough on vanillin. Now I want to talk to you a bit about some of its derivatives. So what I mean by that is very similar molecules, both in structure but also their smell. And I just want to talk to you a little bit about the different, let's call them variants of the vanillin molecule that we can also go and use in perfumery. So I will be showing you the molecular structures for these molecules, and that's just because I think it's very interesting how you can see visually in the picture of it that with just a very slight change to the molecule, you actually get a similar smell, but also a notably different smell. So I'll go through all these molecules, and I'll quickly mention the change, but mainly I'll explain how they actually go and smell. Firstly, we've got that vanillin, And if you have a look at this molecule, you can see that we've got a methoxy group. Now, if you go and switch that to an ethoxy group, that's essentially adding one more carbon with 3 hydrogens on the end of it, well, what you get is something called ethyl vanillin. So essentially there's one tiny change on the molecule. Now, if I go and smell ethyl vanillin right after vanillin, well, it's very interesting because firstly, the actual smell of the two molecules is pretty similar. So ethyl vanillin has this sweet, creamy vanilla smell, just like the vanillin. But the difference between the ethyl vanillin is, well, firstly, it smells a little bit stronger, and you notice that straight away. But secondly, in my opinion, ethyl vanillin is a lot creamier. It's more, I would say it's closer to things like white chocolate. It's just got this really nice kind of marshmallow, creamy kind of smell. Whereas the actual vanillin is slightly, let's say, a bit more back towards the original Vanilla Absolute. It's not quite as creamy, it's just not quite as sweet. And that's called the vanilla in the baseline because we'll be using that as well for the other things. But yeah, this ethyl vanillin is strong and it's sweet, and it's also a base note just like vanillin, so it lasts a long time. And because it's stronger, you don't necessarily have to use as much, though I find personally that if I'm going to pick between ethyl vanillin and vanillin, I would normally do it more based on the actual smell, because if I want that creamier smell, then I would probably go for the ethyl vanillin. If I want something that's a bit more kind of traditional vanilla, then I'll probably go for the vanillin. Now, another thing is people do say that ethyl vanillin is a bit less prone to discoloration, and that's because vanillin and also ethyl vanillin, they do tend to discolor. So that means if you have a clear perfume, then over time they can start to become a little bit brown, which obviously not everyone wants. So there's just something to note there. Apparently if you use ethyl vanillin, that happens a little bit less so. Next then, I'm going to talk about guaiacol. Now if you go and look at the molecule, you've just got this kind of methyl group with an aldehyde on the end, or this little part of the structure. It's just been completely cut off and removed, and apart from that, the molecule is the same. So what does guaiacol smell like? Well, the first thing is it's extremely strong, probably the strongest molecule out of all the ones I've got here. You can smell it from quite a distance, even diluted down. Now the guaiacol to me smells like a mixture between a kind of smoky, slightly leathery molecule and vanillin. So it's this very interesting combination of like a dark, smoky vanilla that's very, very strong. So I haven't really used this much myself, but where I would really imagine that this would be useful is maybe in trace amounts if you want to make the actual vanillin smell a bit more like the Absolute, because remember the Vanilla Absolute's got these dark, kind of smoky, woody facets to it. I would imagine it'd be useful in that. Or if you're working on a particularly kind of smoky, leathery kind of fragrance and you want to add a sweet element to it, I imagine that it would be useful, instead of maybe the pure vanillin, to have something that's a bit more in the right direction already. Next then we have something called isobutane, or another name for it is vanillin isobutyrate, and that's because we've taken vanillin and made an ester with it. So if you go and watch my video on esters, then you can go and understand that a little bit better. But essentially, esters are usually more fruity smelling things, and it's a bit more unusual to go and actually make an ester with vanillin, but it's chemistry, so there's no reason why we can't do it. So that's what isobutane is. And isobutane, so it's a lot more subtle, I find, than things like the ethyl vanillin and the guaiacol. But what it is this kind of sweet, creamy smell. I still think it's more leaning on the side of the ethyl vanillin in that kind of a very kind of like milky creaminess. But to me, isobutane has really got this kind of like white chocolate smell. If you've gone and tasted like a Milky Bar or some white chocolate, I think it's got this distinctive kind of taste that's very similar to how this smells. And I also find when you just go and dip your scent strip into isobutane to begin with, I personally find there's just a slight kind of maybe like fruity facet to it. But I find that for some reason seems to go along with the ethanol. So not quite too sure what's happening there, but I do find it quite interesting, especially because that's an ester, and often esters are just more fruity smells. Next then we have something else which I also think fits in the vanilla category, and that is methyl diantylis. So this one is very interesting, because to me, this molecule really smells like a crossover between vanillin and eugenol. And if you don't know what eugenol is, well, it's pretty much the molecule which is responsible for the smell of cloves. So it's that very warm, woody, spicy kind of clove-like smell. So to me, methyl dientylis smells like really kind of sweet vanilla cloves, which I find very interesting. And if you look at the structures, the structure of methyl dientylis is also similar to vanillin, but it's also similar to eugenol as well to some degree. So again, I find that kind of interesting. But when you can smell it, yeah, it smells like kind of a sweet, spicy, kind of clove-like, maybe a little bit Christmassy leaning smell. I've also heard people say that it can be used in carnations, which is a flower which when you go smell it, it also has those kind of spicy eugenolic notes. I've never tried to make a carnation accord myself, so I'm not sure how it would go, but I definitely can imagine you getting something like that using this note. So yeah, that's the methyl dientylis. This one, it's a little bit more expensive, but I do like it a lot. I think it's worth getting, especially if you like those kind of sweet, spicy kind of smells. The final one that I've got here is something called veratraldehyde, and this is essentially a methylated version of vanillin, i.e. it's had like a methyl group put on the end of it. So this one is a lot more subtle, I find, than the others. It's very kind of, to smell it, you really have to look for it. It's a lot more low-key, but it is there, and you can smell it. And to me, this one smells like vanilla, but this time with a cherry aspect to it. So it's close to something like a heliotropin kind of smell, or like a cherry kind of smell. And I find this one is really nice because it is very subtle, and it can kind of sit there in the base note of your fragrance, and it can add this kind of slight sweet cherry touch. But I find that it also does it in a kind of subtle way, which usually just kind of sits well with other things. So yeah, I think this one's quite nice.
Where's the charger for this one?
Which one?
Where's the charger for this one?
Smells, just because
I don't know. You need to ask Mama.
No, wait. Where's the computer charger?
Also one of the raw materials.
I don't know.
Where's the computer
I
charger?
don't know, Ma.
You know.
I don't know.
Where's the computer charger?
They move. So you need to ask Mama. I don't know where are they.
I'll link in the description, and you can look at the formula for the base note of that perfume, and I think that base note was really, really nice, and it made quite heavy use of the veratraldehyde. Well, that's it. 6 vanilla aroma chemicals and 2 vanilla naturals. Now, hopefully you enjoyed this video. Hopefully you learned something, either just about vanilla and how it's extracted and harvested, or maybe just how to use these things in your perfumes. If you have other vanilla aroma chemicals that I didn't cover, then please do let me know, because there are some that I also don't have myself, and I'd definitely be interested to learn about them in case I actually want to go and get them, because you can never have enough vanilla synthetics. Apart from that, remember to subscribe to the channel if you want to see more videos like these, and I'll see you next time with a new video about something else.
Show you the charger for the computer. The charger from the the charger for the laptop.
Wait, don't.
The charger for the laptop.
No, it's different.
The charger for the laptop.
Long
Where?
time they cannot find that one. Long time, Mama, they cannot find it.
No, for the laptops.
They cannot. For this different. It's different nga.
Where?
That one is different.
Where is it then?
I don't know. Because we moved and everything is lost. When we
But you
moved,
know where it is.
I didn't know. I don't know. I don't know, Mama. Honestly, I don't know. It's different chargers. Really, it's different. No. Why you use that one? Tell me. Nasaan Mama Ocho? Mama
In
Chan?
this video, I'm going to be taking a deep dive into oud in
Mama Chan.
perfumery. So I'm going to be covering what oud actually is. I'm going to be talking about the differences between both natural and synthetic.
You cannot just
Finally,
plug
I'm going to be
whatever you
smelling
can
and
plug
comparing
in.
both
They have
some
different
real oud
voltage
and some synthetic
inside.
oud bases to see how they compare. So then, what is
Use the
oud, also
Mama
known
Ocho's
as
laptop
agarwood?
then.
Well,
She
it
doesn't
comes
really
from
know.
the
Where's your
Aquaria
tablet?
agalocha tree,
Where's your
which is
tablet?
Oh, I
in
know
Southeast
now.
and South Asia. But it's not simply the oil from the tree itself, and that's because this tree has to become infected by a fungus. And once that happens, the tree, as part of its immune response, actually goes and forms this oleoresin, which is just so happens to be fragrant. And this is what is distilled into essential oil, which is known as oud oil. In the book Perfume and Flavor Materials of Natural Origin by Stefan Arctander, one of the go-to references for perfumery raw materials, AVE oil is described as rich, sweet, woody, almost balsamic odor, not unlike that of vetiver oil, something that's found in vetiver, or purified styrene-free styrax, and with a sweetness similar to that of sandalwood oil. So that gives you an idea to what this stuff actually smells like. It's a kind of woody, sweet, incense-like smell with slight hints of smokiness, a bit like vetiver, and kind of sweet, woody notes, a bit like sandalwood. Now, this book, which was written in the 60s, states that the AVE oil actually is not used very widely and it's not produced that much for perfumery. And that was the case back then. But in recent decades, it's enjoyed a surge in popularity, and that's mostly due to the Arabic and Middle Eastern markets. And there's been a lot of demand for oud-based perfumes. It's become quite a trendy thing. And because of that, it's also now been introduced into Western perfumery, whereas, like in the book says before, it just wasn't really there. Despite that, it has been used traditionally as incense in the parts of the world where it's been grown for thousands of years. Now, the thing about oud is that it's not actually that easy to come by. Part of the reason is that there were never really that many of these trees in the wild which are actually infected with the fungus and therefore producing this oleoresin which can be distilled for as smell. So, like a lot of other perfumery raw materials, things like sandalwood, because you could get quite a high price for this on the market, it meant in the last century or so there was a lot of people just going into the forests, harvesting this stuff, and by doing so, kind of making the tree or the plant a little bit endangered. And what that means is, these days, there's not so much of this oud left to be harvested in the wild, although there is some in the wild that is still harvested. Because of that, and the fact that oud is now more popular and well known than it's ever been before in history across the world, the prices of this stuff can go pretty high. It can reach thousands of pounds per gram of oud oil. So, in response to this, two things have happened. Major fragrance corporations have started making plantations where they actually grow these trees, infect them on purpose, and then methodically harvest the oud oil. And then aside from that, they've also started making synthetic oud bases, i.e. bases made by scientists which are designed to mimic the smell of oud as close as possible, using mostly synthetic aroma chemicals, but also potentially other naturals that smell similar to oud, things like cypriol or maybe vetiver. And then they go and blend them together and try to make something as true as possible to the real oud. And while these don't usually do necessarily an absolute perfect job, you can smell the difference, and that's just because these naturals, or the oud itself, is so complex that it's hard to mimic it exactly. There will be molecules in there that we don't know how to produce, or maybe molecules that are important for the smell that are found actually in a very low concentration in the real oud oil, and therefore it's hard to even detect them or why they're important. But overall, we can make pretty decent synthetic bases, and because of that, most commercial perfumes with an oud note actually mostly just use these synthetic bases. And the real reason for that is it's just a lot cheaper than real oud oil, because if real oud oil was in most commercial perfumes at significant quantities, then they would have to be priced much, much higher than they are currently, probably 10 times or more the price. So in summary, there are three different types of oud. There is the synthetic oud, which is not really real oud, but it will give you an oud note inside your perfumes, and this stuff is the cheapest out of all of them, and it is the most consistent. So if you're looking for a smell that you know is always going to be the same, then these do a pretty good job, because like all naturals in perfumery, depending on where they're grown, how they're harvested, that kind of thing, the smell can change from batch to batch. So next we have the commercially grown or more sustainably grown real oud. And this is of course a lot more expensive, but it does at least give you a real oud note. Then finally there is the wild oud. Now according to Ensar Oud, which is one brand selling these wild ouds, the wild oud is the best oud that you can get, and that's because usually it's been growing a lot longer in its kind of natural conditions, so you've had a lot more chance for the kind of resin to develop fully, and the natural, let's say, terroir, or the kind of surroundings, or the natural environment, the habitat of the tree, allows it to apparently develop more complex smells. Now, obviously, I don't know if this is true, or they're just saying that to sell their stuff, but I wouldn't be surprised if it was. Now, with the wild oud, it's